Hey 7th grade, Mrs. Hedrick here. Today is April 30th. This is Math 7. You and I are working in Lesson 21. So we are at the beginning of the lesson on page 204 and 205. Grab your book. Here's what I have. I've got my pencil. I have a ruler. We're going to need some sort of yarn or twine or something. So go look around the house, a shoestring, anything. You need something flexible because we're going to measure around these circles, okay? And I do have scissors to cut mine. You technically don't have to have scissors. And I also have a calculator, okay? So that's a lot of stuff. So hit pause, run and get your supplies, and come on back. Okay. All right, let's take a look at what we're doing today. This is kind of fun. So we're working on area and circumference of a circle. So we're going to be working on circles. Let's take a look at what we have in our problem for today. Use what you know. In this lesson, you will learn to find the distance around a circle and the area of the circle. Look at the take a look at this problem. Okay, so just to be clear, the distance around the outside on a circle, they don't call it perimeter, but that's exactly what this is. They don't call it perimeter because they're not straight edges. Does that make sense? Like, it's not going around a rectangle. Polygons have flat sides, circles do not. But technically, the distance around the outside is also its perimeter. So if I stood here and walked around the circle, what's that distance? You know what area is, right? If I shade this in, that's the area. Okay, let's read our problem. Find the distance around each of these three circles. What is the relationship between the distance around the circle and the distance across the center of the circle? Okay, so we're going to measure around the outside of it, and then we're going to measure across, going through the center point, and we're going to see if there's a relationship between those. Okay, all right, so let's move on down. Let's see what they're asking us to do. Use the math you already know to solve the problem. Record the distance in centimeters. So they want this in centimeters. So I do have a ruler. I went to grab this. And it does have centimeters. Okay. All right. Use a string to measure the distance around each of these circles. Record the distance. Okay. So I'm just going to take mine and like cut a piece off here. Okay. So very carefully, I've got twine. It's a little fuzzy, a little hairy here. I'm going to measure. I'm going to try to cover the outside of my circle. It won't be perfect, right? But I'm trying to get pretty close. What do we think? That looks pretty close. I'm going to cut mine off so I can measure the exact distance. Okay. I'm going to use my little ruler for now, but you can't really see that. Okay. So circle A. So I've got to find 0, which actually mine's right at the end. And I'm going to stretch, not stretch, I'm just going to flatten it out. I've got about, what do you guys think? 9.5 centimeters, so 9.5. So I'm going to go about 9.5 centimeters. You try it, see what you get. Okay, now if you want to pause me and do your own circles, do that and then come back. Will this one reach? Ooh, that one's pretty close. This is what was left of my string. Let me go around. Oh, they're getting, I can't hold on to it. They're getting bigger, they're harder to do. Okay, they've got a bit of an overlap, so I'm going to try and cut that little bit off. Okay, so here's what I think I have for B. I'm going to measure it out. You do it too. I got about 12. Okay, so I'm going to say about 12 centimeters. Oops. And it's okay if you disagree with me. We just shouldn't be off a lot, right? We might be off a half or so. Okay, and then, so this is A and B, so I'm going to need another piece. Let me cut a big piece off here for C. Yikes. See if I can do this one. It's kind of big. Okay, I'm going to let go for a second. Keep going around it. Ah, I need another set of hands. Gosh, it'd be nice to have a partner, wouldn't it? Well, we're doing the best we can, huh? Okay, oof, that was a pretty rough. That was pretty rough. All right, let's see what I got. Oh, this is long. Ooh, I'm going to say, if I slide this down, I'm going to say about 19. Can you see? I'm really close. I'm going to say about 19 centimeters. Okay, now this part should be easier. Measure the distance across the circle, making sure you go through the center and record. Okay, so I'm going to lay this down here. All I have to do is make sure I can see the center point. See how I can see it right in the middle? All right, I'm going to put 0 on one side. And look, that looks like about 3 centimeters. Okay, let's do B. I'm going to go about 4. What's my prediction? I don't know. Should it be around 5? What is it? Ah, they tricked me. This one is about 6. That is a 6. It's a little frayed there. It looks a little scuffed. Okay. All right, I think we're done with the ruler right now. Okay. Now it says, divide the distance around each circle by the distance across. So I'm going to take this number and divide it by this. So like if I could put a fraction bar between these. So I'm going to do 9.5 divided by 3. So grab a calculator. Let's type that in. So I'm going to do 9.5 divided by 3. 9.5 divided by 3. And I have 3.166666666. I'm going to leave it there. Actually, here. Right? Isn't that the technical way? All right. Now I'm going to do 12 divided by 4. I don't need a calculator. 12 divided by 4 is 3 centimeters. And now I'm going to do 19 divided by 6. 19 divided by 6. And I've got, again, 3.1666666. Okay. What do you notice about the answers to the last problem? What do we notice about these? They're all about, what, 3 centimeters? What are yours? I'll give you a hint. The book wanted me to say they were all close to 3.1, but my measuring here wasn't the best. So if you got them all 3.1 something, that's good. All right, describe the relationship between the distance around the circle and the distance across the center of the circle. So if we divide the distance around the circle by the distance across the circle through the center, but I'm not going to write all that. It should be around 3. I should probably do a wavy. It's about equal to 3. It's about equal to 3. Maybe a little more than 3. Okay? All right, let's go to the next page. Now we've got some vocab. Oh, did I show you that I had a highlighter? Oh, you might need a highlighter too. Okay. All right. Let's read through this. For a polygon, the distance around the figure is called the perimeter. We just talked about that. For a circle, the distance around the figure is called the circumference. So let's highlight that. So I'm just going to do, for a circle, the distance around the figure is called the circumference. It's a capital C. If they abbreviate it, you'll see a capital C. A circle is a set of all possible points in a plane that have the same distance from a point called the center. So this is not a difficult concept. The center is the point and the center. So they're going to be the same distance. So let's say a set of all possible points that's the same distance from the center. So this, if you want to highlight it, that's your center. Actually, you know what we should do? We'll just label it center. That's the center. Okay. Another vocab word, diameter, which is, notice that's a lowercase d. The diameter is the distance across the circle through the center. Oh, do I have colors? What do I have? Okay. I'm going to highlight it. I'm going to go orange. Okay, and then I'm going to highlight it. This is the diameter. It goes all the way across the circle through the center. Okay, what's my next one? Let me see if I have a... Oh, I'm out of colors. Oh, man. Okay, that's okay. All right, I'll go yellow again. The radius is the distance from the center to any point on the circle. So the radius, lowercase r, oh, sorry, I'm a little crooked. This is the radius. Okay, radius goes halfway across, diameter goes all the way across. Diameter has more letters, so it's longer. Radius has, right, fewer letters, 6, 3, 4, yeah, okay. So it's shorter. That's how I remember. Diameter goes all the way across, radius goes halfway across. And then here it says the diameter is twice as long as the radius, so diameter equals 2 times radius. So you could highlight that. Notice those are all lowercase letters. The only one that's capital is circumference. The ratio of the circumference to the diameter. This is what we just did on the other page. We took the distance around the outside and divided it by the distance across the circle. That is the same for every circle in the world ever. So if you went around the world and measured every circle you could find, car tires, soup cans, circles in like buildings, windows, and anything. And if you got an accurate measurement, now human error, that's what happened to us. But the closer you could measure, if you multiply circumference by diameter, you're going to get the number pi, which is the Greek letter, right? This is the Greek letter. Usually we kind of draw it with a wavy line and 2 legs coming down. It's spelled pi, and so circumference divided by diameter is pi. Now, on your calculator, some calculators have the pi button. Mine has it. It's interesting though. Can you see mine? If I turn it on, let me clear it. If I hit the pi button, it stays. Can you see it? There it is. It stays pi. On a lot of calculators, if you hit pi, it'll be 3.14159, da 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 da. For us, whenever we use pi on the calculator, we're just going to type in 3.14, okay? So anytime we use it, I'm not even going to hit the pi button. I'm going to use 3.14. If you hit the pi button and I don't, our answers will be off slightly, right? Because it'll have a bunch of decimal places and I'm only using 2. Okay. If you multiply both sides of this equation by d, you get the formula for finding the circumference. Okay, we need this formula. We have to know this formula. Circumference equals pi times diameter. I'm going to write it in a little bigger here. Oops. Circumference. Okay, circumference equals pi times diameter. We need to know that. Since the diameter is twice the radius, you can also write the formula. So this formula has 2 forms. You can write circumference equals pi times diameter, or you can write circumference equals 2 times pi times radius. Actually, right? 2r, 2 times radius is diameter, times pi. But remember, this is commutative, so order doesn't matter. Okay. In real life situations, approximations for pi are useful, right? We're going to use 3.14, the decimal 3.14, and you can also use this fraction, but I don't know about you. When I'm typing on a calculator, that's much easier to use. Okay. Those are both approximations for the number pi. Okay. Use your own words to explain what would happen to the circumference of a circle if the diameter was doubled. Okay, so I'm going to go back to this picture. So circumference, I'll get it out. What would happen to the circumference? Okay, so what would happen to this if this doubled? Right, so if I kept drawing, and now my circle would be out here. So if the diameter is twice as big, what's going to happen to the circumference, do you think? Hopefully you're going to say it would get bigger, right? All right, let's think about it. So if the diameter is doubled, okay? So if I multiply, let's look at this. If I multiply the diameter by 2, to keep these equal, what would I have to do on both sides? I would have to double the circumference, right? If the diameter is doubled, comma, the circumference would also be doubled. Okay. All right. Some practice work. Okay, so you've got a little bit of homework or day work or class work or whatever you want to call it. All right, you're going to work on practice and problem solving. Let's do pages 229 and 230. Okay, I'll post the homework answers so you can take a peek. All right, not too bad. I like the circles. Okay, and we have a brain pop that you can watch. Did we already watch that? Yeah, you watched it yesterday, so hopefully that was helpful. Okay, my friends, I'll see you later.